Good morning. In today's class, we'll discuss about modulation, need for modulation and definition for amplitude modulation. Modulation. Every communication system, if it has to have a long range communication, then the signals has to be modulated. So modulation means varying some of the parameters of the carrier wave in accordance with the message signal. In a communication system, the information will be modulated by different types. One of the modulation is called amplitude modulation. Now we'll see what are the advantages of modulation. The first and foremost advantage of modulation is that using modulation, the height of the antenna will get decreased. We'll see how this happens. Let us consider message signal. All the message signal, that is they are the baseband signal, will fall within the range of 0 to 20 kHz. For example, let us consider message signal with frequency 15 kHz. In order to transmit the signal, now we are going to calculate what is the required antenna height without modulation, and we'll also calculate what will be the antenna height with modulation. The formula to find the height of the antenna is given by Ht equal to lambda by 4. The lambda is the wavelength, and we know the relationship between lambda and c. The lambda equal to c by f. C is the speed of the light and f is the frequency of the signal. Now substitute the value of f and c in the formula. Ht now becomes as 5000 meter. So this is a very huge value. So this is the height of the antenna that is obtained without modulation. Now we'll see what will happen if the same signal is modulated by a carrier wave. Now consider the signal is modulated by a carrier wave whose frequency is 1 MHz. Apply f equal to 1 MHz in the formula. We get Ht, that is the height of the transmitting antenna, to be equal to 75 meter. Now compare the height of the antenna before modulation and the height of the antenna after modulation, and there is a huge and vast difference. It is from 5000 meter to 75 meter. So thanks to the modulation. So this is the importance of modulation. Another important advantage is that when we use modulation, it avoids mixing of signals. We know that all the baseband signals occupy the same frequency band from 0 to 20 kHz. So signals will get mixed up when several transmitters transmit the baseband signal simultaneously over the same channel. So using modulation, each baseband signal is modulated at different carrier frequency. So this avoids mixing of signals. Assume that we have got 5 baseband signals. To each and every baseband signal, let us apply 5 different carrier frequencies. For example, let the carrier frequency C1 equal to 1 MHz, C2 equal to 10 MHz, C3 equal to some 500 MHz, like so on, so that each baseband signal sits on the carrier frequency and they travel with a different carrier frequency. So this avoids mixing of the signals. The modulation also increases the transmission range. We know that the attenuation factor of a signal increases in low frequency. So that if you want to decrease the attenuation, we have to go for high frequency signals. So any baseband signal when gets modulated using a high frequency carrier will result in the decrease in attenuation. Thus the attenuation is reduced, and since we are using a high frequency, we can increase the range of transmission. Using modulation, multiplexing is possible. So multiplexing means we will be having different channels transmitting some different information, and all the signals can be transmitted simultaneously in the same channel. So using modulation, various signals are transmitted in the same channel using multiplexing method. And the next one is that using modulation, we can attain good quality reception. For example, if you use frequency modulation and digital coding techniques such as pulse code modulation (PCM), so both of these type of modulation improves the quality of reception by minimizing the effect of noise. So these are the important benefits of modulation. So let me recall, modulation is varying some of the parameters of the carrier wave in accordance with the message signal. So based on the variation of the parameter, there are different type of modulation such as amplitude modulation, frequency modulation, phase modulation and some other digital type modulation. Now let us first discuss amplitude modulation. In amplitude modulation, it is very clear from the name itself, the amplitude of the carrier signal is varied in proportion to the instantaneous amplitude of the message signal, keeping the frequency and phase constant. This is known as the amplitude modulation. So this is an amplitude modulated wave. So when you look at the wave, here the wave has two signals, that is modulated signal, modulating signal and carrier signal. So we have got unmodulated carrier signal, which is a constant one having constant amplitude, constant frequency and constant phase, and along with it we have got the message signal. So message signal is the envelope. This is the envelope. Okay. So this is the message signal. So this message signal will have varying amplitude and frequency, and now we will see how the signal gets modulated using amplitude modulation. Now the message signal is travelling with the frequency of the carrier wave, so that the carrier wave now assumes the shape of the message signal, and the message signal will be travelling over the carrier signal. So this is an unmodulated carrier, and we have got crest and trough. Crest is the maximum amplitude point, trough is the minimum amplitude point, and along with this we have got the carrier signal. So this VC, V minimum, V max are very essential when we calculate the modulation index. So this is the amplitude modulated wave. So let us consider modulating signal. So remember, a modulating signal is a signal which is the electrical equivalent of an information signal without modulation. So that is called as the modulating signal or baseband signal. So the baseband signal or the modulating signal cannot be transmitted over long distance as such. So we go for modulation. So in amplitude modulation, we have taken a carrier signal whose amplitude, frequency and phase all are constant and higher compared to the modulating signal. Now we are going to modulate our message signal with the carrier signal. So both gets modulated. So upon modulation, now the modulated signal assumes the shape of the message signal, and the frequency of the modulated signal is the frequency of the carrier signal. This is how the amplitude wave looks like. So in the next class, we will discuss about the modulation index. So remember V max, V minimum, so that we can discuss the next class for the calculation of the modulation index. Thank you.